Hello and welcome back to the DIF. I'm Joe and you're joining us here in the DIF studio once again for the start of week 2 at the Disruptive Innovation Festival 2018. And if you were listening closely at the DIF launch party last Tuesday, you'll have heard that part of our theme with the materials and design topic here at the DIF is about reconnecting designers with materials. That was something that Liz Corbin of Materium spoke about during that launch party. We need to reconnect designers and everyone with the materials that are around us that we use every day in our lives. But why should we learn about them, and perhaps how should most of us begin to engage with these marvellous materials that surround us? Well, today we're going to be doing some materials and making right here in the DIF studio. We've got the dust sheet down because I'm joined by Dr. Zoe Laughlin, who is going to take us through some materials, what are we calling them? Experiments?
Demonstrations, who knows?
Zoe is a bit of a materials superstar. I'm going to call you that. I think it says that on the session page.
Does it?
I think so. It's in writing.
Where's my cake?
And you've been on talking about materials on TV, radio. People have seen you cropping up in some documentaries quite recently, which maybe we'll get into them a bit later on, some of those topics around materials and maybe some of the really current issues with materials and the way that we're using them and maybe misusing them in today's society. But first, we're going to get into something a bit more hands-on, which I've got to say, I think that's a first for the DIF.
I hope your table's up to it.
It's a bit wobbly. Zoe, what are we going to make today to get into the topic of materials and making?
I really want to show you how materials transform and that things that we have around us every day actually have gone through incredible processes of making. And I'm just going to begin by...
Oh my gosh.
Yeah. Brace yourselves. Firing up the blowtorch, because I want to show you essentially how easy it is to melt glass, right? So
melt some glass.
Melt some glass.
Okay.
This is a glass test tube, but it could be a glass jar, it could be anything. And this is a blowtorch from your local hardware suppliers. And essentially, this is going to take the glass up to just over 1000 degrees centigrade, at which point it will be soft and you can start to manipulate it. But we're so used to glass being something that is incredibly brittle and easily broken and sharp and cuts us. It's not something soft and malleable.
Because we're not used to it at 1000 degrees.
Not in our daily life, no, but I can now start to twist it, manipulate it, shape it. I mean, you could do this on the hob at home.
Would you recommend it to people? Or is this
Absolutely,
a don't try this at home sort of situation?
Okay, I should say don't try this at home, but at the same time, trying it yourself, doing things with materials for yourself is a fantastic way to learn what they're like. So once the glass is hot enough, you're actually able to, it's not hot enough, pull it, it's cooled down again because I wasn't paying attention. Right, hold on. I don't know how close your cameras are.
Are you worried for them?
It's starting to get sort of chewy.
It looks like a piece of toffee.
Yeah, exactly. Now there, in fact, I'll just stop it for a minute so I don't have to shout. So there's an incredibly fine strand of glass. And now...
It's a bit wobbly.
It's flexible because glass is actually really elastic, but we don't see that elasticity because it's often made in objects that don't show it. But you could make, with a drizzle of glass, you could make a glass spring and it would bounce. It's that elastic, but often it goes beyond its elastic limit. Oh, no, damn it. If only that had smashed, it would have been great. And
you'd have had to clear it up.
and smashes. But this is how things like optical fibres are made, is you essentially heat up the glass and it's drawn down and gravity lets a droplet form and it pulls down and you get this super thin thread of glass. And then it has these incredible properties, which means light will travel down the fibre with total internal reflection. So nothing is lost out of the sides. So whatever goes in one end of the strand of glass comes out the other.
Okay.
So once you've got an optical fibre, you can start doing amazing things with it. If I had made a better fibre, I could use that now, but I haven't. So we'll move on to the next thing I want to show you, which is If you collect materials like I do, and if you're a material enthusiast like we all are at the Institute of
when
Making.
you say, so Institute of Making is based at the UCL, and it's a materials library collection?
It's a physical space where we have our materials library and our workshop living side by side, and it's about materials and processes. For me, making is defined by the relationship between material and process, and our space is a home for all of that. And we celebrate materials from the wondrous to the everyday and tell their stories and provide experience with them, either in the form of making something or just having a go at, prodding something. Who knows?
And how many different types of material are...
Oh, thousands. I mean, it's sort of an embarrassing number.
Okay.
But the world is a materials library, really. It's just a way of looking at it.
Just get that on a T-shirt.
The world, Just putting the right glasses on and looking at the world through that kind of material lens.
And why would we want to stretch glass out so it's all elasticy and like a spring?
Because you get this extraordinary optical property of the glass. So in this material world, there's a type of material which I describe as the superlative. So it's this constant chase for like the lightest light thing, the strongest strong thing, the fluffiest fluffy thing.
What? Do you know what the fluffiest fluffy thing is?
I don't. No one's actually. I've made that one up.
But that one is a challenge.
For example, this is the second hardest stuff after diamond. So only diamond will scratch this, but this will break.
You're looking for something to break. Oh my gosh!
So.
Don't worry, our producer hates these mugs.
So these are both ceramic, right? This is a ceramic mug, but this is a ceramic ball. And this ceramic is more brittle than this one. But this is so unable to be scratched that this will dent anything else it comes into contact with. So if I was to drop this on the floor, it would leave a crater. So you can have mine.
Okay, no,
anyway,
we'll worry about that later.
But this sort of chase for the superlative, and someone came
You were saying about the blackest black?
Yeah, the blackest black. So we had a piece of the blackest black sent to me by NASA. But when it arrived, it was actually grey because it's also very fragile.
Okay.
So all the blackness sort of crumbled away. So things that are really good at one thing often aren't very good at other things.
And this race to find the superlative materials, is that something people just do so they can say they've done it? But they're actually used for things.
They're really useful. And having the lightest solid in the world is really great if you want to... It happens, it's a great insulator, but then people, a year later someone finds that something's 0.0001 better and you can't call it that superlative anymore. But when someone said to me, Zoe, have you heard of transparent concrete? I thought this has got to be a superlative material, surely, what is it? And I had a look they sent me a link, and this was maybe 10 years ago, and it was basically a decorative panel. This company had taken concrete and they'd scattered into it optical fibres. So these incredibly thin strands of glass had been scattered in the concrete and light's shining from one side and it comes up as pinpricks of light through the concrete. So it's the glass that's transparent, not the concrete. And I thought it was kind of interesting. Maybe I should get a bit for the library. So I wrote them an email and they were just like, no. And I was like, well, I'm happy to pay. And no. And I was just sort of annoyed.
NASA were less protective about their blackest black.
NASA were less protective than the transparent concrete makers. And I thought, in terms of motivating you to explore materials and make things, being a bit pissed off is kind of a good motivator. So I had that. I was like I'm a bit annoyed that I didn't get some sample. And then I was invited by RIBA, which is the Royal Institute of British Architects, to give a talk to the architects. And I've always had the pet theory that architects are very attractive. There's something in my mind that makes me think, architect's sexy. And I'm like, okay, this is my chance to impress.
To go to RIBA and impress the architects.
Got being pissed off mixed with impressing sexy guys was the perfect blend to then make some of my own. So I thought, I'm going to have to make some transparent concrete. And bugger you, I'm going to make it better.
So most people just do a really nice PowerPoint presentation.
Yeah, exactly. I'm like, no slides, only real things. So the first sort of iteration of our own transparent concrete is this cube. Now.
So you made that?
Yes, so I need a light, and I've realised I've come without my phone, so I don't have my torch. Let me leave the stage. I'm coming back. I'm back. I'm gone, I'm back. Look, okay. Here is a torch. Where's my camera? Who am I with? Down the lens.
That one
right.
There.
So you'll see to Joe so he can provide
Yeah, that's transparent.
reaction. Can
And
you see
I
my finger?
see your finger. There's a
Okay.
resolution there.
Exactly. So they missed a trick in my mind, which was to arrange the optical fibres in a grid. So fibre sort of A1 is in the same position on both sides. Then you get this analogue screen, right? You get resolution. But then I was thinking that's not necessarily going to woo me an architect. I need to do better. So I thought we could maybe have a go at the next step today. So you can.
So
you
we're
can
going to
move the
make some
debris.
of that architecture wooing transparent concrete.
Hopefully. I need to call upon DIF team. They've been asked
DIF team, come and mix.
come on.
So what are the DIF team going to be asked to do now?
So I'm going to give you each a cup of just dry cement. There you go, grab one. Don't go round that way, stay on this side. Come, tuck in. You can sit down even if you want.
That's comfortable.
We need these.
No, that's fine. Grab a cup. Keep come in. Okay, right, I'm going to give you each a stirring stick. Stick.
I'm not even going to ask the production team if everyone's in shot because I think I know the answer.
Right, I'm going to pour some water in your cup and I want you to stir vigorously.
Okay.
All right? Okay. So let's start at the far end. Stir.
Vigorously, Bledar.
I'll have to come back and give you a top
This
up.
is quick, dry stuff.
Yeah. Stir. Who needs more water? More water. You've dried up.
I think I've failed a bit.
It's all right. You won't die
I'm going to
today.
take a quick break over here.
I didn't have one for you, Joe.
No,
Joe,
that's
you're doing
okay.
all right. Keep
I'm
going.
happy to observe.
Right, so you can do this one.
Okay.
Right, stir.
Gosh.
Okay, so you're mixing up the concrete. Get all the bits on the bottom. Yours is sounding
It's
good.
like a hot chocolate.
Try
If you
and wipe
miss
those bits off the side. That's it. Joe's doing a good. Follow Joe, everyone.
You?
That's it. Have you got all the bits off the side? Yours is maybe needs a little bit more.
While we're doing this, Zoe,
Yeah.
we've had a question from the audience. Someone said, what's the difference between flammable and inflammable?
Well, they both mean it can catch on fire.
So no difference.
No, because people use inflammable for the same reasons, don't
Okay,
they?
so we can interchange on that
Yeah.
one. Okay,
I think.
we asked the audience. No, that one's a silly comment.
Silly comment.
Why do you think designers become disconnected with materials?
Because a lot of the work you're required to do often involves being on a screen and at a computer, really. That's the sad truth.
Do you
of
kind
it.
of get what you're given? You as a designer, there are the standard materials and you don't really mess with them that much?
I think you see it when you say what's that going to be made out of, and they'll say plastic, and you say, well, that's a whole family of materials. What do you mean? And that's the sort of when you do a crit with some students. But I think you can't underestimate, for any type of design process, whether it being designing a pair of shoes or designing a spacecraft, actual contact with the real thing you're making and iterative processes of making as a way of understanding the thing. Right, I think we're ready to pour.
Mine's
Yours is a
looking
bit
silky
slack.
smooth.
Yours is a bit thick. Tip a bit of yours into it. That's brilliant. Right, you're first up. Okay, I'll do it. Okay. Right, let's pour. So,
Oh no! No,
in
don't
here,
drink that water.
this is why we have the dust sheet down. In here is my patented Laughlin rig for transparent concrete. Next one, Joe.
Yep. How's it looking?
Good, perfect. This is a nice, good one.
What happens to the stick? Just throw it on the floor.
Chuck it on the dust sheet. That's why we're here. Yours is good. This is great. Oh no, your lovely trousers.
Don't worry, they're fine. I've got more.
What are you going to do? How's yours? Is yours nice and slack? Yeah, let's get a bit of a slack one. Because this one was a bit heavier.
Oh, that one's a bit.
It's a bit more runny, isn't it?
That is.
That's all right.
Is it still going to work?
I think we're going to be fine. Let's have a look at yours. Yours is very thick. Let's have a...
Were you stirring vigorously enough?
I think you maybe didn't get as much water as everyone else. It's fine. Right. Stirring crew, you're relieved your duties. Thank you very much.
Thanks, Diff team.
Right. No, this is all part and parcel of material experience,
Thanks
right?
to the fantastic Diff team. Okay, how did that go? Are we on track?
This is actually really good. I'm quietly impressed. Fingers crossed.
We've got a bit of seepage down here. Is that okay?
Oh no, that's a drip. It's
Okay.
not. I'm not going to look at it. It is what it is now.
So transparent concrete, which
Yeah.
we've just made, which is still kind of... kind of sceptical whether it's going to be as impressive as your lovely block of transparent concrete there. But what could we use it for?
On a very simple level, this could be embedded into our buildings to channel light and harvest light and bring it into places that are darker. So you could have a whole bundle of the optical fibres on the roof pointing south. You take that bundle and then you split it up and you channel them to areas where you then have a panel that gives daylight into a space. But equally, this is a physical manifestation of the internet in some respects. This is what super high-speed broadband travels down, is optical fibres. And you can embed networks and systems in them as well. So they can carry other types of information, not just sort of aesthetics.
So people will probably be familiar with like fibre optics for when they hear about their latest broadband upgrade. So this is the same sort of...
Exactly the same stuff.
material.
Yeah.
But you've kind of used it in a place where you wouldn't normally find it, within concrete. Are there other kind of material mashups like that around us in the world, where if you pair one material with another or put it in a different context, it could do new things?
In some respects, the world of materials would describe what you're talking of as the sort of composite revolution, when you put two things together and you get something that's greater than the sum of its parts. And there's loads of those things around. But even very simple things are also incredibly wondrous. I mean, staying in the concrete family, this is a piece of what's described as self-healing concrete. So you can have this, or do I need to keep it here?
Well, yeah, keep it there.
Okay.
It's more important that everyone else sees rather than me.
So this is concrete, which has in the mix are bacteria. Now those bacteria are essentially dormant, right? But if they wake up, if they become damp, they will wake up and they will eat a food that's impregnating this concrete as well. And so this happens at the scale of bacteria. So when you have there's two ways you could have a crack. One would be a catastrophic earthquake crack and it's broken. It's not going to help you there. But the other thing is when you see a crack, it's already like 7 years old because of the slow stresses and strains in structures. That's what this is designed to deal with. So you get a small hairline crack, moisture gets in.
So the sort of damage that would occur through just kind of everyday erosion or wind and rain and ice, that sort of thing.
Yeah, and just the sort of stresses of being a structure and standing in a certain position means that the building has stresses on it. And those stresses will cause cracks, moisture gets in, the bacteria wake up and start to excrete out a material which heals the cracks in the concrete. So I can't snap this in half, dip it in some water and it poo itself back together. This is bacteria poo at the hairline crack stage, but this is a living responsive system.
And is are any of your friends at Reba or any other of your architect friends, are they using this?
I didn't get any phone numbers.
None.
Can you believe it? Outrageous.
Is anyone using that sort of thing?
So this is currently going through all the trials it needs to be certified for use in buildings. So they're building structures in Germany with it and testing it because you have to get your EU standards number before you start building multi-storey car parks out of it. But this is the sort of future of the built environment we're looking at, those kind of grown, living composite materials.
And with all the thousands of materials that are in the library and examples like this, you must see materials used or used in the wrong way quite often. Does it frustrate you when amazing technology isn't more widespread, or when you see things just used in the wrong way?
It can be upsetting when you see things that don't have a material sympathy, or that it's just using something because it's the cheapest thing and it's not necessarily the most elegant way of using that material. Or you often find objects in the world that actually have huge amounts of care given them and are incredibly beautifully made things that are incredibly simple yet designed to be thrown away. Right? We recently went to a landfill site and it is, as far as the eye can see, it's full of familiar everyday stuff. Mm-hmm. And it's stuff that we have all owned and we have all thrown away at some point in our lives. Like, you can't say that you haven't. Like, we have all thrown stuff away. We've all gone down the street and put something in a bin. And that thing is now lying there, and it's this detritus of everyday life. It's so familiar, but it's also so incredibly sophisticated. To be able to injection mould and make that thing and make that lid screw onto that bottle.
Things that we take for granted.
And be airtight, like, that's wondrous. and it's kept the contents so fresh and so fizzy when you open it. But that bottle is given so little respect that it's put in the bin. But at the same time, it's not our fault. What else do you want us to do with it?
Some would argue that the way that we design things, we often put materials together or mix them up in a way that makes actually making use of them at the end of their life quite time-consuming or expensive or not possible. And that's one of the many, many reasons we don't bother getting stuff back when it's finished with. When we look at, you said about composites, or we've just mixed two materials together, is that...
And that's a one-way street. I mean, entropy doesn't go... This concrete, you can't melt this down and turn it into more concrete, or this is locked. And that's why... So they've discovered recently that the Colosseum in Rome is a concrete structure and is self-healing because they used ash from the volcano nearby that naturally contains the same bacteria that do this self-healing property. But concrete buildings from Roman times are still around and they're still standing, which is sort of great, but it's also a symptom of the fact that it was no use knocking it down, taking the bricks and building something else with it. It's not a building it's not a material you can do that with. So other buildings that would have been made out of stone were taken down and the stones get reused because it's these sort of material units that have another value to them, whereas that's not the case with concrete. And
sometimes, are you saying sometimes that's okay to have something that is a one-way street, that you've combined some materials and you won't be able to separate them again?
I mean, maybe it's not okay. Maybe it's not okay, actually, because, I don't know, it's a bit like, I know it's immoral to eat meat. It is, but I do it and I'm sort of okay with it because society hasn't made me feel so bad about it. But I sort of feel like actually that won't continue and we will eventually go, yeah, it's immoral. How did we ever do that? Like, how did we ever have slaves? But at the moment, we're able to deal with that morality and it isn't something we have to worry about. And maybe it's a similar thing with the material. Like, we do use it with gay abandon and mix and match and make, because that's the thing is what we're after, and what happens to it afterwards isn't as thought about. But I think we will get to a point where it will be immoral to use that thing in that way and people won't stand for it.
We've got some good questions coming in. Do keep sending them. You've got the discussion box to the side of the video that you're watching us on now, and also on Twitter use #ThinkDiff. And Colin Webster, DIF legend, who we'll hear a bit more from later on, will be looking out for those questions and sending them to me. We've got one more on the transparent concrete, who says, Joe, who says, as interesting as it is, transparent concrete is still concrete, carries with it all of the same environmental issues as normal concrete. Where can material innovation help designers apply circular economy principles? Or circular economy, first time we mentioned it in this session, there's loads of it on at the DIF. You familiar with the topic? How can we make better concrete?
You probably shouldn't use concrete then, is the bottom line, really. That's what comes back to trying to think of units of construction that can be taken apart again and used again. And just concrete isn't that. Unless you make a concrete brick and you build a system where this slots into that and the wiring, it comes down to designing better systems and processes, I think.
When we had Liz, your colleague and friend Liz Corbyn, on the show last week, we played Jenga. And one of the questions she had on her materials Jenga brick was actually, what's your least favourite material? And she kicked up a right fuss and said, you can't have favourites, especially not least favourites.
Good girl, well done, Liz. That's
okay.
Fine.
I was going to ask you.
No, I don't.
not the materials library. It contains hundreds, thousands of materials. Even ones that might not be desirable or might not be worth celebrating? Are they in there?
Absolutely. I mean, I can't even imagine what such a thing could be. What do you mean? Like, no, but it is. We will have the stuff from NASA, but we also have, chocolate and my baby teeth and things.
Your specific baby teeth.
Yes, okay. Specific. The tooth fairy came back in later life and gave them back to me. So there are everyday things, and that's sort of the point. Is that I really don't believe in things like smart materials. To me, everything's smart. It's just you haven't asked the right question of it yet. It's like there are materials which are sort of maybe more gratifying or more, the story somehow is sexier, but actually they have their disadvantages too. And this forgotten one, you just need to tease something out of it and treat it with, you know, the right sort of mindset. And suddenly it's an absolute delight, and you need to be shouting about. See, I can't even think of something that I couldn't then tell you something interesting about. Do you know what I mean?
Yeah.
I don't know.
No, I think that's fair. I mean, Liz gave the example of plastics, that there is, whilst it's the current poster boy,
course.
it does amazing things as well.
Yeah.
I think, going back to something you said earlier, that you were, after the transparent concrete, your first run-in with transparent concrete, you were a bit pissed off, which led you to try and make something yourself, something better actually, try and make it yourself. Do you think if more people got pissed off about the materials that are perhaps being used improperly around us, for example, in packaging, that they would try and more people would be coming up with better solutions?
Yeah, I think it's a very big motivator. You find something frustrating, you're like, oh my God, I can't bear this. You give me a napkin, I'm going to chop this table up because it's so annoying. Like, we've all done that in a restaurant, like if you've been annoyed by something. But if you haven't actually got the means at your disposal to do anything about it, then maybe it just simmers away and that's the end of it. But I have a workshop, I have the means to be able to try and think physically and do something about it. So I would stand up for the rise again of garden sheds, bringing tools and processes back into people's homes to enable you to make things and make adjustments to things and engage with material again.
And are you a materials scientist we had a question here about your backstory,
Okay.
your origin story.
Yeah,
I called
yeah.
you a superstar at the start of the show. Why are you so
Who am
interested
I?
in materials? And this person said that they read that Mark Miodownik, another colleague of yours at the Institute of Making, was first attracted to materials after he was stabbed by a knife. Have you heard that one?
Yeah, I mean, that's what he would like to put in. That's what he put in his book. But, you know, we're all a very good myth
So
story.
what's your origin story?
I'm the child of farmers. So both sets of my grandparents had farms. And I think it's very difficult to have that environment and that mindset around you and not be encouraged to engage with the world in a physical way, and for it to be okay to have a penknife when you're 5 and things like that. So that's very much sort of where I came from. But I wanted to make things and went to art college first because that was the quickest route to being allowed to get up to stuff, as I would describe it. Like
Mischief.
Yeah, exactly. And you could do that, and art college didn't have a problem with that. But a lot of the questions I had about the things I was making and the materials I was using and the ideas I was trying to capture had scientific answers, and I wanted those answers. It wasn't just about the questions. I wanted to solve those problems. So then did a PhD in materials in an engineering department. So I'm a sort of hybrid materials engineer, scientist, artist, designer, maker. I'm a person who loves materials, really.
And you said about the garden shed, could anyone do this sort of thing, or maybe a better question is where would they get started with doing that? If they don't need necessarily a qualification or a degree or a permission to do it.
There's a lot. I mean, there's a lot you can do in your kitchen. There's some great tools there. You can melt metal on your stove. Sometimes there's an idea of a thing, so you could take something that already exists and adapt it and change it. And even if it's as simple as taking a knife from your kitchen and fashioning it a better handle, you could do that with some polymorph, which is a low temperature thermosoft plastic, which you could melt in hot water, squidge to a shape around your hand, insert your knife in and have a bespoke grip. And that could be a useful intervention if you have arthritis or you have trouble holding things and you've got a weak grip. So you could adapt and change the world, or you could just start afresh and be like, I want to learn how to make a thing. And what would be a good route? I mean, evening classes are fantastic if you want to have a go at pottery or have a go at carpentry. These are great places to start because you don't need to invest in a load of kit. You can use their kit and then think, yeah, this is for me, and then get something yourself.
And I actually want to ask you about a few more materials you've got on the table, but before we go there, is there a kind of higher kind of purpose to doing that sort of thing? Some people would say that's tinkering, that's almost hobbyist stuff. Is there a bigger purpose behind all of that?
So I really believe, I get I have to sort of zoom right back a bit. So your eye of innovation, right? I sort of bristle a bit when people start talking about innovation because often it becomes something that's to do with a type of approach and a type of funding and maybe a certain selection of subjects. But I really believe innovation is a symptom of the human ecosystem of activities that we get up to. And that breadth of human culture really is it should be exhaustive, and our ability to roam in it should be free. And that if I want to know about sharpness, and I might need to speak to a physicist who can talk about an atomic edge and how you generate a single atom sharp thing, or I might need to talk to hairdressers about scissors and the best angles to approach cutting things at. And that knowledge doesn't live with one person or one discipline. So if you're at home and you're curious about things, don't limit what you're interested in. I've completely forgotten your question as well, because I was going to zoom into...
It was about whether there's a kind of higher purpose to
Yeah,
it.
because that's the higher purpose, is you don't know where these things will lead, and to genuinely trust. So at the Institute of Making, our workshop, we allow anybody at UCL to become a member and use it. We have 2 rules: don't be an arsehole and no weapons, right? So, and what we really mean by that...
Are you
there's a few
paraphrasing,
other, some other rules. But in essence, we're saying we're not going to say some project's more worthy than another. If you want to make a Christmas present for your mum, that's fine. If you want to do a multi-million-pound research project on heart valves, that's also fine. And that the value in tinkering and playing earlier actually becomes your material intelligence to make a really interesting decision about how you're going to design the very tail end of that heart valve and how it attaches to the body, because you've had some knowledge that comes from when you made some shorts for your summer holiday. Who knows? And I think ruling stuff out isn't helpful. So just do whatever interests you and later trust that that is going to be useful knowledge and it's going to lead you to some kind of interesting moment of innovation. I don't want to say that, but...
I think my stirring is going to come in handy.
Very innovative stirring. I feel like innovation, it's a bit like beauty, right? It's not for you to call yourself beautiful, Joe. You are beautiful. I'll tell you that. But if you go around saying I'm so beautiful, we're like, what a wanker.
Like if I went around saying I'm so innovative.
Yeah, exactly. I'm so innovative. Like, tosser. You're not innovative. And it actually also stops you. It's probably the best way to not make and do something innovative is by setting out, we're going to do innovation. And then you're like, oh... you're not doing it. It sort of instantly makes it harder to do innovation. I
think our production team, just having really enjoyed you calling me a wanker there. Let's.
It'd be beautiful. So
a beautiful one. That's good. Let's have a look at some of the other goodies that you've brought in.
Okay. So in terms of fibres and the fibre optics, right? Material. It's very difficult to separate material from the structure it's in, and that's at any layer, any sort of degree of magnification you wish to look at that structure. You could zoom in but take, for example, something like steel, which we all consider instantly kind of monumental as these big, immutable forms made of steel. Exactly, a girder. But I have here, this is steel, which is the 10th, each individual strand is the 10th the thickness of a human hair. This is steel which is finer than silk. It will float. Oh there we go. Probably not even being able to be picked up on camera. But this steel is spun, and it's in this form. It is a new material, right? In the sense of the chemist to go, oh yeah, okay, it's steel. But in terms of us in the world, this is a very different material from a steel girder. But this is a fibre which can then be spun into yarn. Or hang on. In fact, to prove it, here's a magnet.
Oh my gosh.
What else is going to break? So this gets, if you spin this, so instantly you need to talk to weavers and spinners and people who know how to create yarn from fluff. Like you've got fluff, what could you do with it? Well, speak to textiles people who know about spinning it into
maybe you
yarns.
wouldn't speak to necessarily it becomes less useful for a construction project. Perhaps.
Well, but
don't rule it out.
Don't rule it out, because once you've spun it and you've turned it into a yarn, this may look like a standard cotton thread, but that's 100% steel. Yep. You will not be able to snap that. I mean, give it a good go. Careful though, because you might slice your hand. But it's soft and it's string-like, but you could use that in a suspension scenario. I mean, you could hang a car off something that thick.
Really?
Well, maybe not. It depends how big a car. But,
Next year at the DIF, we'll try it.
But this stuff that just looks like a cotton thread that you could use in clothing, now, because it's made of steel, has this super strength to it that is a combination of the shape it's made out of, because of the friction of the yarn, and then the material from which it's made, all combined to give this amazing stuff. But it's all still steel, but it's a different material. I'm going to put that down. Anyway, there's another thing that's on the table.
It makes me think, are there a set number of materials? Because this is two completely different things. If you've lost that.
I was told beforehand, don't put anything down that hole, Zoe, because you will never get it out.
Well, at least it wasn't one of the more valuable items.
I'm going to move that ball.
That's almost two completely different materials, as you've just demonstrated.
It's two different materials.
And they're two materials that are different from a steel girder. So it creates this sense that there's almost infinite possibilities once you start changing the structure as well as actually what it's made of.
I mean, there is no such thing as materials, really. There's only structures. And that's fine. But we use materials and have names for things to be able to cope with the world. But once you can look at the periodic table, and for some disciplines that would be the materials. But then you ask architects, and they have a different palette. And so the palettes change depending on what scale you work at and what your discipline's like. But really, for me, there's only a kind of material object conversation, which is when you get a thing in the world, what shape is it? What function is it performing? What's its properties? What is its properties? What's it like? And what name are we giving to it? And you can get all sorts of different materials. Yeah.
We're going to come back. I'm interested as to why you brought a jar of water.
Yeah.
But you're going to tell me that in just a moment. Next, we're going to hear from Colin Webster, kind of a big deal. And we're going to hear about what's coming up shortly at the DIF.
Hey folks, Colin here. I'm going to talk about 3 shows I really think you should watch at the DIF. The first one is on tonight at 7 o'clock UK time. It's called Empowering People to Repair for a Circular Economy. You'll hear about the Right to Repair movement, about repair cafes and how we might initiate a culture of repair for our otherwise short-lived products. Now my top pick from last week is this one, Safe and Circular by Design. Now, if you're enjoying this show with Zoe Laughlin, then you'll really love this podcast because it takes a further look at the materials world and it includes an interview with Cradle to Cradle's Bill McDonough. It's well worth listening to. And finally, don't miss our feature documentary, System Reset. This documentary looks at a part of the story of change that's blowing through our economy. It looks at new production methods, about digitisation and urban planning, the circular economy and, well, much more. We launch it on November 15th, that's this Thursday, so make sure you make a note of it in your diary. Right, that's all from me for now. Back to the hairiest man in the DIF team.
Hello, we're back. Thank you, Colin. I don't think that was a compliment. But Zoe's got words for you, Colin, if you're watching out there.
Colin, what's this about biscuits?
Biscuits. Colin's been spreading rumours about Zoe's love for fancy biscuits.
Apparently it was like a rider, like I'd only do this if there were fancy biscuits.
But you want to just clear your name.
It would clear my name. Colin offered biscuits. Would you like biscuits? Yes, please, I'd like biscuits. Who wouldn't like biscuits? Now, it's come back to them as if Zoe's demanding biscuits.
Any biscuits in the materials library?
I have built a biscuit breaking machine so that you could compare different ratios of fats and sugars. So if you make a fattier biscuit, how it changes its snap, or if you make a more sugary biscuit and then it becomes more crumbly, how it changes the snap. So I made a sort of biscuit crushing tester. But there's actually no biscuits.
I have no words. I'm going to take a couple of questions that we've had. We've had one from the DIF chat box. What's the best material to be used for reusable food packaging? Is it PLA because it's fully compostable and recyclable? So it would help me a lot with my project, it says Andre.
So I wonder if the reusable food packaging... So he means like Tupperware, I'm presuming. Like, not packaging...
Is that... maybe it is Tupperware?
It sort of is that sense in which it's a unit, like a jam jar, where stuff goes in it, you seal it up, you can transport it around, you use the stuff up, and you could refill it. I mean...
I get the impression you're you're a bit more, almost a bit ambivalent as to maybe what the
I think there's
material is.
the problem is you could specify all sorts of materials with the best intentions, but you also need to design a system that enables that intention. So you could have, let's say, a BPA-free plastic that wasn't going to damage you and it wasn't going to damage the environment and had a 35-year useful life as a food container. But it comes down to you as the consumer deciding that it's the right thing for your packed lunch. Or you can say, okay, you're only going to get, right, let's zoom out. You like the milk bottle. You get your milk, my parents get it delivered in the countryside in a glass thing. They put it back out, it's taken away, it's washed. So it's the system that takes it away again that makes it useful. So you could imagine someone like an Amazon, something really massive, like your supermarket shopping. They don't just drop it off, they pick up those containers again and fill them up and send them back to you. But you have to have that system, otherwise the container is just another nice thing that could go in a design shop.
I'm sure when you went to this landfill recently, there were lots of nicely designed suitable materials that were suitable for their individual task, but because the system wasn't in place, they ended up in a dump.
Yeah, and ceramics and glass are great for this, but they're also heavy, so they're not great because if you're transporting around them, they're going to take more energy to shift them. So there's trade-offs in all places, but it's one of those problems that there isn't one solution for. But if you can potentially in this person's project say, here's my container, but also here's my idea of the system that will interact with that container, I think it makes for a more powerful potential product, I think.
Let's look at a couple more of the materials you brought in just before we run out of time, and I'm left wondering why you brought a jar of water.
Well, so from the fibre optics, there are other things that have other amazing optical qualities, and in that jar is an entirely invisible material. So, but it's only invisible in water. So light passes through the object in there, through the material in there, in the same way as it passes through water. So it's bent at the same, what's called refractive index, as light through water. So there is something in there. If we have something to pour it out into, let's get one of these cups, I can prove it.
Gosh.
So if I just then drain the water away, slowly will be revealed. Actually,
It does look like
that.
there's... Are you sure they're in there?
There's,
Someone-
well, at the moment it's bubbles,
Ah.
but suddenly it's full of sort of marbles. Now, we just call these invisible balls, but this is the same stuff
Ooh.
contact lenses are made out
It
of.
feels like a giant...
It's like a jelly
it's like an
gummy
eyeball.
bear or something, or an eyeball.
I
It's
like
nice.
it. I like
sort
that.
of bouncy. Oh, there it goes. But on cue, but these they have this wondrous optical property, but that's sort of it. The only other use I've come across for them is florists use them in flower arranging to have a vase of water with a load of these in, and then stems standing, but they look like they just stood there, but yet they're held up by these invisible balls.
They used to use that funny foam stuff,
Oasis, yeah.
and now
And they can
that's-
use these.
Okay.
But the other thing is they will slowly give off water. So water will come out of them slowly over time. So the vase won't deplete of water as quickly as it would if it was just
Are
empty.
you hoping to get all of these back or not?
It's okay.
Great, because I'm going to keep one, I think.
But
Oh.
they're lovely things, and they're sort of delightful, utterly delightful. And I don't know if we've got a good shot. Let's wait. Can the camera see this? Right, I'm going to pour the water in, and you'll see them go invisible again.
That's cool.
So yeah, optically they are now invisible to our eye because the light's passing through them in the same way as it's passing through the water.
Lastly,
Next.
just a quick run through of the other things you've got.
Okay, this is a piece of malachite, which is the rock from which we get copper. So coming back to this, what is a material? Even something like copper that's a pure element on the periodic table, to get it, it's a highly made thing. Right? This has gone through a process of making in the sense of a geological process to create this rock. But then for us to get something we would understand as copper that we could make wires from, we have to smelt this. We burn it with coal. The oxygen and the carbon in the coal rip let me start again. This is copper oxide. So you've got copper and oxygen in here. You get the carbon in the coal. You burn it. The carbon bonds with the oxygen to create CO2. So it rips the oxygen away from the copper. So the copper oxide just becomes copper. At the bottom of your furnace, you're left with slaggy bits like this. So here you've got bits of copper showing. You then melt that down. You then begin to process it. So there's a huge... The point I'm trying to make really is, where is the material? Where is the
people would
process?
look at that bit of copper and say, oh, that's the raw material. But there are many stages before that.
But equally, if you were in a research lab making high-tech alloys, you order copper in powder form because you can measure it out like 300 grams of or 2.298 milligrams of or something. So that's no use to you. So this has to go through a huge number of processes to make their raw material, which is pure copper in a powder form. So, like, what is copper and where do you get it is not as straightforward. I mean, but also people die to get this stuff. Like, there's a lot that can be said about the processing of this material to get this, to then get other things, to then get other things, to then get copper in a fibre form that you can send electricity down.
Electronic devices, things like that.
Yeah. So anyway, I just wanted to have them there to represent this constant process of making that materials are involved in. Yeah.
And this one that looks like a bit of bird poo.
The bird poo, this is a little off-cut, sort of, off-extrusion, little spillage from the process of milk bottle recycling. Oh. So when you melt down
keep it here, otherwise
your
I'll
milk
get told
bottles,
off.
melt them down and you can then form it into new milk bottles. But you'll notice it's slightly green. That's because in the process of making or recycling plastics, the plastics come in, they're shredded, they tumble down in a sort of waterfall of confetti, and there's cameras looking at that confetti falling plastic. The cameras are looking to identify white plastic, and then below the cameras are little air jets. And as it falls, the air jets go and they blow the white plastic away from the coloured plastics.
So the coloured plastic would be like green lids?
Everything, yeah. So at the bottom, you get two hoppers, one full of the white plastic, one full of the coloured plastic. Then you can melt that white stuff down and use it again, because the white is the premium product, because you could dye white other colours, but you can't dye, even if you got all the blue stuff together, you couldn't necessarily get this exact blue. Like, it just becomes more Play-Doh effect. It will end up as sludge. So the white is the premium stuff that's really worth recycling, so they try and get it. But the most popular milk in this country is semi-skimmed, and that has green lids. So if the chances are, if a bit of coloured stuff gets into the white stuff, it will be a little bit of green. So this white product always ends up turning a bit green because of that contamination. But you'd think the people who do that processing, they went to speak to the supermarkets and tried to persuade them to just have white lids, and they were like, no, the British people, they need their coloured lids. And they're like, what, really, you can just have a sticker? Like, no. But anyway, they've eventually got them to reduce the dye content, so they're a less vivid green, but...
They still do the job of saying, this is semi-skimmed.
Exactly. But it's sort of madness. It should just be white lids. Then you wouldn't get that problem. So that's what that is.
So a design challenge there, or what you just described sounds like a lot of effort at the end of the problem, or when that problem has already been set in motion, really. So if we went back to the design phase, you could have a different outcome.
Yeah, but also it comes round to people at that level realising that. So, for example, there'll be companies who say, we've got this bottle and it's being marketed on, it's a fully recyclable shampoo bottle or something. But they'll say, oh, if people buy it, then we'll turn all our range fully recyclable. But that puts the onus back on the consumer to somehow choose. But what you begin to realise is all they've got is the packaging at the end of the day, because that shower gel for men and shower gel for women is the same stuff, really. I mean, maybe there's different perfume, but when it's in a grey bottle, it's definitely for men. You see what I mean?
Oh, yeah.
So all they've really got is that. So to then legislate and to say all single-use bottles for something like shampoo should just be white with white lids, that could be done tomorrow, and that would need to be done at a legislative level. But what it then does is it will mean a completely different design process. It will mean, it will put at risk that sense and reveal all we've got is the fact it's in a grey bottle. And, you know, it changes the commerce, and it becomes quite a disruptive thing to do, I think.
Well, I'm going to skip over your last material, but I'm going to recommend, there's a fantastic video of Zoe putting a chalk ice on a block of this. This is this mycelium insulation.
Yeah.
And heating it with her trusty blowtorch. And go on, find it on YouTube or something.
I think it's on the BBC website right now. Okay. Secret Story of Stuff.
And you can see how well this mycelium, mushroom-based insulation protects from 1,000 degrees. Secret Story of Stuff, you said it was called. We've got time. Well, we haven't really, but I don't care. We're going to ask one more question. Someone said it's great to hear how passionate you are about materials at this intersection of kind of designer, maker, artist. Are there other designer, maker, artists that you've met that are, or that are people that are receptive to this way of thinking about materials? Because it does seem quite unique. A lot of people approach it from the chemistry angle or design angle, maybe a bit of maker angle, but the artistic element as well is something that's often missing.
I think over the sort of easily the 15 years that since Mark and I started working together and founded the Institute of Making, we always describe it, we've not only collected materials, but we've sort of collected people, and that the family has grown and more people have said, yeah, no, I'm on board with this. And that may be from individual artists who want to do some sort of collaboration or it chimes with their practice, or it could be the students that we're teaching that sort of go out into the world with this new mindset. But I think there is a definite movement, and there are definitely people now who I think would be traditionally sort of in that art college mould, but are taking a much more rigorous scientific approach to the thing they are making. And be that someone like Jane, who founded Sugru, and who essentially, as a sculptor and a designer, invented a new material and put that out into the world. There are now hundreds of people sort of working in that space where they're not making and designing objects and things with names like pliers, but are designing and making materials for other people to make other things out of. But that's their end product, is this new material.
And I've got two last questions from me. One, when's our lovely transparent concrete going to be ready? Oh. Are you tempted to
demould it now? I think it needs another 5 minutes. We won't rush it.
We'll show this at the next DIF show. We'll demo it in all its glory. And then lastly, just as we've covered it a little bit. You have here's one you made earlier. Go on then.
Because I'm a pro, you know.
Not your first rodeo.
No, look. Here's one I made earlier. Let me get the torch up. So the idea is, with the fibre optics, light will go down, and that could go around the world and pop out the other side.
And it wouldn't have lost its
So
vibrancy.
This is the light. Let's turn the torch on. The light's now going to go in here, and it comes out here. So
it's like a light.
It's now going round a corner.
Periscope type thing, but without mirrors.
Exactly.
That's very impressive. I can't wait for ours to
I'll
be
give
revealed.
this to you as a present. I shall
Thank you, Zoe.
Donate it.
Why should people question what they know about materials?
Why should people question what they know about materials? Because you don't know the whole story, and I think everything is more complicated than potentially it first appears, and maybe you shouldn't question. Not everyone should, because otherwise you'll end up in a sort of like paralysed by thinking you know too much, and now you're sort of crippled by it. So I don't know. Why should we know? I think I can't help myself, right? And I think some people will be like, yeah, I can't help myself too. What does that smell like? What does this taste like? Like, I want to know those things. And I very much appreciate that not everyone else does. So I'm not about to say everyone should start licking concrete. But I think if you do, you will know the world differently, and you will experience your daily life differently. You'll be more aware of an edge on something, or the slip of something, or the acoustics of something. And I think that's a richer place to be in.
There you have it. Learning about materials and the world around us will make it a richer place to be. Dr. Zoe Laughlin, thank you for joining us, partially destroying the DIF studio,
Yes.
but for taking us through this exploration of some of the materials that are around us every day. Thank you very much for joining us.
You're welcome.
Thanks to you guys for watching at home, asking all those great questions and sitting with us for another fantastic DIF session. Tune in for the rest of the week. Loads more coming up, as Colin explained earlier, and we'll see you next time. Bye.